So now that we have finally mastered mole calculations, we are going to build off of this skill and use mole ratios in order to figure out the amount of reactants or products we have in a reaction. So this is where stoichiometry comes into play. And as you guys remember, stoichiometry is just a fancy name for mole ratios. So let's start with the one-step mole ratio problems. What we are always going to begin with is a balanced equation. And lucky for you, I have balanced this equation already. So we have zinc plus hydrochloric acid yields zinc chloride and hydrogen gas. So let's start with number one. What number one is asking, it says, how many moles of hydrochloric acid would react with 7 moles of zinc? So, just as a refresher, the coefficients in a balanced equation tell us the mole ratio of each reactant and each product. So if we look here, we have 1 zinc, 2 hydrochloric acids, 1 zinc chloride, and 1 hydrogen gas. So let's go back to our question. It says how many moles of hydrochloric acid would react with 7 moles of zinc? 7 moles of zinc. So we see in our reactants back here again, we have 1 zinc to 2 hydrochloric acids. So you may be thinking, well, this is really simple. If we have 7 moles of zinc, then we're going to have 14 moles of hydrochloric acid since it's a 2-to-1 ratio. And you are right. However, I want to show you the basic form to do this, so we have something to build off of as these problems get more difficult. So as always, we are going to write the quantity we are given in the question. So we are given 7 moles of zinc. And with these types of problems, our units are going to be a little different. Because we are going from moles to moles, we want to put what moles we are talking about. So for this instance, 7 moles of zinc. We're going to put mole Zn. Simple as that. Now, we need our conversion factor, and in this case, it's the mole ratio. So, in our numerator, we always put what we want to end with. And in our denominator, we put what we want to get rid of. So in this case, we want the number of moles of hydrochloric acid. So going back to our balanced equation right here, we see there are 2 moles of hydrochloric acid, and again, I'm going to do HCl at mole HCl as the unit. And there are 2 moles HCl for every 1 mole of zinc. So again, we want to end with moles of HCl. We want to cancel out moles of zinc. And we press Shift Enter, and it gives us our answer, 14 moles of hydrochloric acid. Pretty simple, just like we thought, but again, we need the basic formula. So let's go to number 2. It says, how many moles of hydrogen gas is produced if you react 3.5 moles of zinc with excess hydrochloric acid? Now, don't let the excess hydrochloric acid confuse you. It's just saying that we have more hydrochloric acid than we need in this reaction. But what we're interested in is how many moles of hydrogen gas we'll get if we put in 3.5 moles of zinc. And again, you may already know the answer to this by looking at the ratios, but I want to go through the process with you. So we begin with our given number, 3.5 moles of zinc. Then we're going to next put in our mole ratio, so we can go from moles of zinc to moles of hydrogen gas, because that's what we want our ending number to be. So we want to keep moles of hydrogen gas, so that's going to be our numerator. And if we look, we have 1 mole of hydrogen gas to 1 mole of zinc. So this is pretty simple. 1 mole H2, again, the new units, to 1 mole zinc. Shift Enter, and we get 3.5 moles of hydrogen gas. So what we are taking advantage in these types of problems are the mole ratios given by our balanced equation. And again, the coefficients in these equations tell us what the ratios are of moles to moles. So I want you to go ahead and do numbers 3 and 4. And at the bottom of this homework sheet, there is a form for you to insert your questions. So go ahead and do that, and you are all set.